So today, class, we're going to learn. Did I start that? Did I start that?
Is that combination?
I did. So the joke of the day is I bought a HP computer with a fancy sound system, but it broke. And this guy told me you should have bought a Dell. I said, yes, she has a much better sound system than my computer. Okay, so
Terrible.
moving on.
Oh, you saw it!
Hey,
I run tomato! I can't find them. Get off the stage.
Put those tomatoes back in your pockets. Anyway, so how many different, so here we're going to start with the counting principle, okay? Which says how many different Chipotle burritos, Chipotle, whoops, I should have capitalized that. Chipotle burritos.
What kind of meat do you get on your burrito?
We're getting there. Can you make, and we're going to make the choices pretty simple. Given 4 different meats you could get, 4 meats.
What are the 4 meats?
3 sauces. 3 sauces. We're going to kind of keep it simple, even though there's way more, and 2 types of beans. 2 types of beans. Do you guys know what the answer to that problem is?
42.
Yeah.
24.
It's 24. Okay? And that's called the counting principle. All you do is you multiply together the different combinations. So, so you can think about it. So say if I go to Chipotle, you can get like chicken, right? You can get steak. What else can you get? Carnitas. What's that, pork? You could get carnitas. You could get steak. Or you could get something barbacoa, right? Barbacoa, okay? BBQ. Yeah, but that's not. So I'm just making up. And then 3 sauces. So you could get green, red, or yellow, right? It's kind of right. Wait, is there more than that? There's actually 4 sauces, aren't there? Green, yellow. Okay. Anyway.
Well, if you get like.
So green, red, yellow, green. Let's just say, okay. Green, red, or yellow. Green, red, or yellow. Yes? You don't have to write this down. And then for beans, you could either get pinto or black, right, for each of those choices. So you could see altogether what it ends up being is I have 4 times 3, right, because there's 3 choices for each of those, times 2 for each of those. So it's all you do is you multiply the different choices together. So and basically all you have to do is go 4 times 3 times 2, and then you would get 24. So in reality, there's way more choices than that, right? Because when I go to Chipotle, I get I like a little red sauce and a little green sauce, and then you want guacamole, and then you got your rice or no rice, or you got your. And if you're a Boulder, you have to get gluten-free tortillas, you know, and stuff like that. So I don't know if they make gluten-free. I think they do. But and then you could they have like corn tortillas or something, you know, and then you could get lettuce and cheese or no cheese and all that kind of stuff. So that's part of why I think that Chipotle has been so successful, because even though they have very limited ingredients, which are pretty healthy ingredients for the most part, they have a whole, you could like change it up, you know, so you could like get like hundreds of thousands of different combinations given all those.
Oh yeah, you can get something every time you go.
Yeah, so if you want to, yeah. So although I get the same thing every time. So that's called the multiplication principle. Do you want me to write that on board? I'm going to write it, okay? And I'm going to use my computer to write it because I can write better with my computer. So I'm going to get this, okay? You ready? Here we go. I'm going to go like this. Where's my keyboard? You see a keyboard somewhere on here?
Right.
Here?
No, right.
Here.
What's that?
I think that's it.
Oh yeah. That's it. Text.
Text. Look at that. So I could go like this.
Is the next thing, is the thing next to it a calculator?
What? But I can type it on here, okay? So this is called the multiplication principle. Can I do this? Where's it showing up?
Yeah, we should go to the Rockies game in this class and to Chipotle.
We should,
Let's
yeah.
go to Chipotle, right?
I'll be so good.
Yeah.
Actually, no, I wouldn't because I don't have my wallet.
Wait for the program to respond. Sorry. We're having issues. Okay? So this is the multiplication principle, which says that if there are P choices for the first task, Q choices for the second, and R choices for the third, then the number of different choices is P, that's a time sign, times Q times R, because I couldn't find the dot. I guess I could have used parentheses or something. So say you are at the, so then we have some different types of problems. Will you please put your cell phones away? Thank you. Right? So say you have a problem like this, and you have, so how many different, whoops, okay, why is it doing that? Oh my God. Okay, so using the counting principle, please stop flipping the coins. How many, we'll do probability later, okay? How many different three-digit area codes can you have? Area codes. How many different three-digit area codes? So think of this as the counting principle, okay? How many choices do you have for the first number?
9.
9?
10.
10. I guess if it could start with 0, we'll just assume that it can start with 0, because you have 0 through 9, so you have 10 choices. How many different area codes can you have for the second? 10. Okay? And then how many for the third?
10.
In reality, I think you can't have a 0 for the first digit, right? And so you would have, instead, in reality, how many choices would I have for this one? 9. How many choices would I have for this? 10. 10, 10, right? So this would give you 1,000, but in reality, you probably really only have 900, and then obviously there's some ones that you can't use, like 911 wouldn't be a very good area code to have, you know, because that would get you into trouble, right? So there you would have 900 different ones, okay? What if repetition is not allowed? So same question, but let's say, what if no repetition, no repeated numbers, okay? And you have to, and you can't start with 0. And you can't start with 0. Can't start with 0.
Are we doing reality based? Or?
Okay? No, theoretically. Okay? So how many choices do I have for that first digit? 9. Now, how many choices do I have for the second digit?
8.
You still have 9, because you can use a 0 for the second. So here I couldn't use a 0. Okay? But here I can use any number other than the one that was immediately.
Spell your name wrong.
Oh, come on. Oh, you are done.
Okay?
You better take
Probably
a
a
seat. You're not
parking
coming
issue.
back. You're going to jail.
Okay. So here, how many choices for this one? 9. And here, how many choices for this one? 8. Right? Yes?
And then be 9 because, I mean, you have one, you can't do the second number, but you can do the other ones. Because they're not repeating, because they can be the
For
same
this one.
They can be the same one as the first one, just can't be the same one as the second
No,
one.
it can't be. You can't repeat any digit.
Oh,
So
okay.
you couldn't have like 711. Okay?
No, but what about 1, 7, 1?
No. Okay? So yeah, that would be 9 times 9 times 8, whatever that comes out to be. Okay? So Then,
Why is the first one only nine?
what?
So you can't start with 0.
Because you can't start with 0. So it says, what if no repeated number and can't start with 0? Okay? So that's that. All right? Then ways to arrange things on a shelf. So say we have, how many different ways can 8? So then you'll see problems like this. How many different ways to arrange 4 cans of 8 colored paints on the shelf. So I don't know if that problem is clear. In other words, you have 8 different colors and they can't be repeated. Okay? And so you have
Do you have 4 of each color?
no, you have 8 paint cans sitting on the floor. Okay? And so you have 4 spots to put those eight different color paint cans because you're gonna make a display. Now,
Why would you want to know that?
So to arrange 4 cans, maybe you're working at Home Depot, right? And you want to figure out, okay, I only have 4 spots for yes, sir.
Can you close the door?
Yeah, go ahead.
Yell at the door.
Okay, no,
Just sitting there.
Sorry.
Oh, boy.
So, how many different ways to arrange 4 cans of 8 different color paints? So you have 8 cans of paint sitting on the floor, right? And you're working at Home Depot and you're trying to win Employee of the Year. So you want to have a different display for every day of the year, right? So you take your 8 different color paints. How many choices do I have for this spot? How many choices? 8. So say I choose yellow for this spot, let's just say. How many choices do I have for here? 7. And so say I choose yellow and blue, then how many choices do I pick? 6. And then 5. Okay? So that's known as something that's known as a permutation. Okay? And the way you would write that is 8 permutation 4 on your, or sometimes they write it as 8 4 like that with a P in front because we did combination. So it's yeah, we'll get there. Okay, but it's 8 permutation 4. Okay, so a permutation is when order matters. Okay, permutation is also what you have when you have a cat that has like 5 legs on it. Okay, that's a permutation. Okay, permutation is an ordered. It's an ordered arrangement of objects. I made that one up. I never told you guys that one. Alrighty, Jeff would have. It's too bad Jeff is in jail now. An ordered arrangement of objects. Yeah, he's not really. We probably just had a parking issue. All right. So permutation or arrangement of objects, and when you find a permutation, so n permutation r means, or permutation of, this is said, n objects taken r at a time is equal to n factorial over n minus r factorial. So in this case, in this problem, it would be 8 over 8 factorial over 8 minus, yeah, it's a radio station, 8 minus 4 factorial, which reduces to 8 factorial, 8 minus 4 is 4, over 4 factorial, which can be thought of as 8 times 7 times 6 times 5 times 4 factorial divided by 4 factorial. And what happens to those 4 factorials? They cancel out. See? So that's why it's 8 times 7 times 6 times 5. See? So permutation is the number of objects over the number of places you have to put those objects. Okay? And that's the way you can do it algebraically, but you can just think of it as 8 times 7 times 6 times 5 in this case. So that's a permutation. Right?
So
Then,
should, just later on that,
yes.
should the n minus r be in quotes?
Should n
be
minus r-
well, in parentheses?
So the n minus r.
No, to the left.
Oh yeah, you're right. Sorry. Thank you. That should be in parentheses. Okay. And then, so let's just do a couple like quick practice ones. So say I had, I don't know, 20 permutation 3. Okay. So this is a permutation, not a combination. So what would that look like? What is that? Yeah, it's just, everything okay?
You scared?
Yeah. You want this?
No, you're okay?
Yeah, I'm good.
You had to get out of jail free card?
I did.
Yeah, good. So it's just 20 times 19 times 18. That's a permutation. Any questions on that? What would 50 permutation 1 be? It'd just be 50, right? 50 objects, 1 place to put them, okay? So you have 50 different choices that you can make for that one. Right, so that would just be 50. What would permutation of 50 permutation 50 be? What would that be?
1.
That would just be 1, right? Because that would be 50 50 minus 50, which would be 0 factorial. And, oh no, that would
That'd be
be,
0.
this would be 50, this would be 50 factorial. Be 50 times 49 times 48 times 47 times 46. That's a lot of combinations, okay? So N, P, N, like that, is equal to N factorial, okay? So if you have N objects and N places to put them, then you're going to have N factorial different combinations. For example, say you have 11 baseball players, right? On a team, that's all you have. You have no spare baseball players. And how many different batting lineups could I have? 11 players on a team. 11 players on a team. On a team. How many different batting lineups? There's only 9 players in the batting order, right? Sorry, I messed up. Okay. 9 players on a baseball team. I should make up problems as I'm going. 9 players on a baseball team. How many batting orders? How many batting orders? Okay? Yep. So that's just 9 factorial. Because you have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? So that's 9p9, or which is also equal to 9 factorial. And that's a lot. Right? So with those 9 players, you could have a lot of what is it? Come up to me?
362,880.
362,880. So if they say, no, Jake always gets to bat third. I want to bet third. He goes, oh no, I only have so many different permutations that I can make with these kits. And you say, that's not right, because my math teacher said there's 362,880.
Do you not like that hardcore?
Okay. All right.
When was the last time you Wait, that's how many different permutations?
What?
Batting orders you can name?
Out of 9 players, yes.
I think that's just relation together the Rockies game.
What?
That's justification to get out of the Rockies game.
So Austin asked, how would that change? Austin asked, how would that change if there's 11 players on the team, right? So that would be 11 permutation 9, right? Because you have, that's a 9, okay? So there's 11 players, right? With 9 spots to put them in, okay? So it would be 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. Now you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you could think of that as 11 factorial over 11 minus 9 factorial, right? Which is 11 factorial over 2 factorial, which ends up being this, right? And you can do that on your calculator. Want to see how to do it on your calculator? I think it's a big number. I don't know. Let's bring up our powerful graphical calculator. Okay, I will. Okay, so with 11 players on a team, okay, with 11 players on a team, oh wait, you go 11, then 11, then you go to math, and then you go over to PRB, because this comes up a lot in probability, and you go to NPR, okay? National Public Radio. And you hit 2, okay? And then you hit 9. And you should get some really big number.
9,958,400.
Yeah, exactly.
Wait, did I say 9 million?
That would be, so comma goes here, comma goes 19,958,400. So if you have 11 players on the team and you say, Brad always gets the back cleanup, I want to back cleanup, and the coach says, no, there's only so many different ways I can arrange it. You tell them, no, there's 19,958,400 different bad orders.
But
strategically,
like subtract out all the orders where you put your that's their.
Yeah, we're going to get to them. Okay? So next, did I stop the timer? Did I stop the, was I on pause? No, I wasn't. All right. So now we're going to talk about combinations. Actually, combinations. And a combination is, and we already talked about this in the previous chapter when we were doing binomial theorem, but with a combination, order does not matter. It's an arrangement. Combination is an arrangement of objects. Sorry about the sloppy writing. Where order does not matter. So, for instance, how many different 3-person committees, we'll make a simple one. How many different 3-person committees, committees, is that how you spell committees? I don't know. Can be made, let's make it easy, from 7 people, okay? So you have 7 people to choose from. So if this were just a combination, and so it's kind of nice to think about, am I in the way? Okay. So how many choices do I have for this spot? If I have 7 people, how many different choices? 7. But then I've chosen this person, right? So how many do I have for this person? 6. Okay? But then I've chosen that person. How many choices do I have for that?
3.
Okay? So, 3. You meant 5, right? You meant to say 5. So, this would be a permutation. 7 times 6 times 5. But order does not matter, right? And so, say in these spots I choose Jeff, I choose someone else, Molly, and I choose Cassie. All right? So say Jeff was here, Molly was here, and Cassie. These are, out of those 7 people, these are the, that's not how you spell Jeff, sorry. Okay? There, okay? GMC, trucks. There we go. So how many different arrangements of G, M, and C are there? Well, there's GMC, right? There's GCM, right? Greatest common multiple. There is there is CMG. That's the ticker symbol for Chipotle. Chipotle.
Really?
You're in the stock market, yeah. Okay.
Oh,
There's
yeah, Chipotle Mexican Grill.
CGM. Okay. There's CGM. There's MGC. And there's MCG. So, because there's 6 different ways I can arrange these 3 people, and order doesn't matter. So all of these on a committee are considered the same, right? Doesn't matter who goes where. So what do you have to divide this number by?
3.
You have to take this number and you have to divide it by, this is 6, right? So I would go 7 times 6 times 5
200.
divided by 6, right? Which is 7 times 5, which is how much?
35.
35 different committees you could make if you did a combination. Okay. Now the other way you could think about that is 7 factorial divided by 3 factorial. What we did before for 7 factorial, 3 places to put them. Times 4 factorial, okay? And the 4 factorial, this, so a combination, or n combination r can be thought of as n factorial over r factorial, which is the number of spots you're putting in, times n minus r factorial. Okay? So in this case, that would be 7 factorial. Well, just right here, right? 7 factorial, 3 spots to put them. 7 minus 3 is 4. And that's how you would do it algebraically. Okay? And we talked about that in the last chapter. Or you could get those combination numbers off Pascal's triangle. Remember how I did that? Okay? With Pascal's triangle, if you could do it by hand this way, you could use your calculator, or you could use Pascal's triangle. Okay? Yes, sir.
That part where you did 7 factorial over 3 factorial, 4 factorial, is that like another way to get the same answer?
Yeah,
Oh.
because, like, if you think about it, it'd be 7 times 6 times 5 times 4 factorial, right? Divided by 3 factorial times 4 factorial. What happens to the 4 factorials? They go away, and 3 times 2 is 6, and those go away, so I get 7 times 5, which gives me 35. See? Pretty.
Why would you do that way? What's that way
Why would I do it that way? Because it's just like plugging into a formula, and it's easier to do than write out all the things like that, and then what do I have to divide by? Okay?
for? Okay.
Yes? You good on that? All right. So a couple more combination problems. Here's another combination. What would 7 combination 2 look like? And sometimes I write it this way, and sometimes I write it this way. What would that look like? And you don't have to do it with that factorial. How many spots do I have? 2. What goes in here? 7. What goes here? And then what do I have to divide by? 2 factorial. See? Because that's the number of arrangements of those 2 things. Say these are, you have 7 letters of the alphabet and 2 places to put them. Okay? So you have A, B, right? Or you could have what else? No, if I chose A and B are my one group of letters that I chose, how else could I arrange A and B? B and A, right? So that's why I divide by 2 factorial. Okay? So basically, this is the number of spots you have, and then you divide by that number of spots factorial. Okay? Or you could think of it as 7 factorial over 2 factorial times 7 minus 2 factorial, which is 5 factorial, right? Which would, and that's equal to 7 times 6 times 5 factorial over 2 factorial, 5 factorial. The 5 factorials would cancel out, and I get 7 times 6 divided by 2, which is 21. Different arrangement. See? Yeah? Okay. Anything combination 0 is just defined as 1. So 7 combination 0 is 1. 7 combination 7, what's that? That's 1 as well. Okay? Because basically it's 7 factorial divided by 7 factorial. Okay? That's what it comes down to. Okay? And so combination order does not matter. Okay? So for a combination, there's going to be way less than a permutation. Permutation, like, there's only one combination of you 3 guys if you're sitting in the front row, but there's 6 different ways I could arrange you. Okay? So that's
not including if you don't include the other two.
yeah, if I don't include the other 2. Okay? So see, you thought this was going to end soon, didn't you? But there's more. Okay? So what if I have a committee? Okay? So here's a new committee. Let me see if I spell committee correctly. Okay? Committee. How many different committees? Am I still recording? Committee. Committee? 2 E's?
2 weeks.
2 E's. Okay? How many committees with, okay? So you want to do this committee like the, what's it called? The SIT committee, or the student teacher committee, or the, what's that committee called? The PTSO committee, or STUCO committee, or there, we used to have the, what's that other committee? I don't know. But they make decisions, right? So say you have a committee of, you have 10 students, and you have 6 teachers, and to choose from. And you want to make a committee, make a committee with 3 students and 2 teachers. How many different committees could I make? Okay, make a committee with 3 students and 2 teachers. So for the student committee, what would that look like? Is that a combination or a permutation? Combination. So you have 10 combination, what? 3. And then you're going to times that by how many teachers? 6 combination 2. See? Because you multiply, because that's multiplication principle. So to do that, that'd be 10 factorial over 3 factorial, 7 factorial, times 6 factorial over 2 factorial, 8 factorial, 2 factorial, 4 factorial, and you can figure that out, or you can do that on your calculator. Okay? You can do that on your calculator, right? and I get, I didn't do it, but you could figure out, you could figure that out using your calculator, just by multiplying it out. Questions on that? Sorry. Uh-oh. Okay. Last thing. Okay. So this next thing, last thing I promise, okay? This next thing is called a permutation. Permutation with permutation with non-distinct. Distinct? Is that how you spell distinct? Distinct objects. Okay. For example, what was that word we were using? Committees.
Did you
Okay.
have a hard time with like spelling bees in second grade?
Yes. Second grade. How about Mississippi? Do you know how to spell Mississippi? How many different, okay, distinguishable arrangements are there for the letters in the word Mississippi? And we'll try to keep the capital out of Mississippi. Mississippi. Like that, right? That's right. Mississippi. Okay? So this would be a permutation. Right? Any of you guys play that game? Word with Friends? That's still out there? Last year, a couple of years ago, that was the big rage. Okay? So how many letters are there?
4.
4?
11.
I mean, how many different letters altogether?
4.
No. How many different letters? Count the letters. 11. So that would be, so if it were just an arrangement, that would be 11 factorial. But unfortunately, okay, I have some repeated digits, right? So what I have to do, I have I. How many different I's do I have? 4. So what I have to do, 4. So what I have to do is divide by 4 factorial, because that's the number of arrangements of those I's. So when I did 11 factorial, I'm counting each one of those arrangements with the I's as a different arrangement. But it doesn't matter if I goes, so if I have these letters, it's indistinguishable whether this I goes here or this I goes there, right? And so what you do is you divide by 4 factorial for the I's. And then, how about the S's? How many different ways do I have to arrange 4 S's? So then I divide by 4 factorial for the S's, okay? And then so this is the I's, right? This is the I's. This is the S's. What else do I have that's repeated in here? P's, right? So I have 2 factorial ways to arrange those P's, right? So if this P were here or this P were here, it doesn't matter, right? They're indistinguishable. And so what I do if I have a problem like that, if there's repeated letters, I divide by the number factorial of how many letters there are. Okay, so if I did that out, I would get some answer. I'll let you figure that out. How much?
34,650.
34,650. 34,650. Thank you. Okay? And here's just the last example. Okay? Now, so you are working at the used car lot. Okay? Because you didn't do your pre-calculus homework. and he ended up with a job selling used cars. Okay, and so how? Last one, yes. How many different? Last problem. Okay. Arrangements of cars, and these are cars lined up, okay, are there given, not cars just kind of in a lot, okay. You have to use all of the cars, so you have 7 red cars that are indistinguishable, kind of bad, okay. 7 red cars, 3 blue cars, 3 blue cars, and they're all exactly the same. And you want to make it look different each time. 2 whites, and 2 whites and 1 yellow. Sorry. Red, white, and blue. Have 1 yellow. Okay? So, how would I do this? How many cars are there altogether? So it would be 13 factorial. Out of those 13 cars, how many red cars are there? 7 factorial, 3 factorial, 2 factorial, and 1 factorial is just 1, so you don't have to worry about it. You follow that? Okay? So, because it doesn't matter if this green car goes here or here, you can't tell them apart anyway. What? Or, sorry, the red car, not the green car. But probably, if you knew how to do that, you wouldn't be working at the used car lot anyway, right?
Yeah, well, they use this stuff.
What?
How to use the car a lot.
Anyway. Okay, so, or maybe you're working at the new car lot and you're bringing home the big coin. I don't know. I have to stop talking. Page, homework. Oh, there's a lot. Page 890. Some of them will go fast. 1 through 7, 12, 15, 890, 15, 17, 31, 33. It's on my website. 35, 37, 41, 45, 48. Some of these will go real quick though. Okay. 50. This is just for you, Sam. 52, 53, 57, 60, and 65. Okay? That's all. And remember, you heard it here on Mr. Leader's Cutting Edge. 42 minutes. Who's going to listen to that? Oh well.